In this lecture, we will be seeing another example of conversion of regular expression to its equivalent finite automata. So here we have a regular expression given, and our task is to convert it to its equivalent finite automata using the rules that we have studied in the last lectures. Alright, so let's get started and see how we can do this. So starting with the first sequence, we have A or B and its all closure. So this symbol over here is same as the plus symbol that we used to use, which is used to denote OR. So why I'm using these different symbols is because I don't want you to be confused when you see these different symbols. I want you to know that this plus and OR just means the same. So first of all, let's try to make the finite automata for this sequence A or B its all closure. Okay, so let me take a state which I will call state number 1. And let me make this the starting state. And if you see that this is a closure, so whenever we have a closure, what we do is we make a self loop. That is what we have studied. Now when will it go to this state? On either A or B. So on either A or B, it will go to this state 1 itself. Okay, so now we have completed the A or B closure part. Now let's come to this part. Now if you see here, you see that after this sequence it's like an and it is followed by A, B, B or A plus B, and this plus is not a plus in between A and B, but this is a plus over this A, and we will see what it means. So first let's do this part A, B, B. So for that, let me make another state over here which I will call state number 2. And we already studied that whenever we have sequence of the form ABB, that means if there is no plus in between, if it is just written together like this, that means you just have to make separate states for them and make them keep moving forward. So from here, this state 1 will go to state 2 on getting input A, that is this A over here, and then I'll make another state over here which is state 3, and I will send this state 2 to state 3 on getting input B, which is this B over here, and there is one more B. For that I will make another state which I will call state 4, and state 4 will also be a final state because this is a terminating symbol, and this 3 will go to state 4 on getting the next input B. Now we have completed this part A, B, B, and followed by this we have an OR symbol which is followed by A plus B. Now whenever you have an OR symbol, you have to continue from the state where you started. Now here this is the state from where we started, this ABB, and since it is an OR, this also will be followed from this same state itself from where this was started. Okay, so let me make another state here which I will call state number 5, and I will send this 1 to 5 on getting input A. Now we are going to design for this A plus. Now what is the meaning of this A plus? A plus, if you remember when I taught you the identities, I told you it means one or more number of A's. So it could be A, and it would go on. Now what is the difference between A plus and A closure? In A closure, it can also include the empty symbol and followed by any number of A's. So the difference is that in A closure, there could be 0 or more number of A's, but in case of A plus, it will be 1 or more number of A's. That means at least one A should be present. So as we design for this A plus over here, what we do is, in this state number 5, I give a self loop and I put A over here. Now if you look at this state 5, which is for this A plus, we see that it will come to state 5 only on getting at least one A. It will come at least on one A, and after that it could get any number of A's. So we make sure that at least one A will be present, followed by any number of A's if required. So we have successfully made the automata for this A plus. Now it is followed by a B. So there is nothing in between, it is just written together. So for this B, I'll just make another state which I will call state 6, and since that is also the ending symbol, so this will be a final state, and this 5 will go to this state 6 on getting the input B. So that is for this one. So for this A plus, we have designed this, and for this b here we have this part. So now we have successfully made the finite automata for this regular expression. And if you look at this finite automata, you may be thinking whether this is a DFA or an NFA. So if you look carefully, we can find that it is an NFA. So we see, if you look at state 1, on getting input A, it has moves to 1, 2 and 5. It is having more than one moves. And also if you look at state number 2, you see that it goes to state 3 on getting input B, but it does not have any move on input A. So all these things are properties of NFA. So we see that these are NFAs that we have designed, and it is obviously possible to convert this to its equivalent DFA. So if you want to convert a regular expression to its equivalent DFA, so first design its NFA like this using the process that we have done here, and then after that you can convert it to its equivalent DFA using the conversion of NFA to DFA method that we have already studied in the previous lectures. So I hope this was clear to you. Thank you for watching, and see you in the next one with another example.